Welcome to my channel.
Good day! Today, I am going to solve problems using Python. The problems were given by our teacher who is Mr. Jelvi Lagos. So let's start. Our problem number 1. What is the smallest number of coins that can represent $1.56 using quarters, dimes, nickels, and pennies if all coins must be represented? So the total amount of dollars is 1.56. Our code will be from math. We are going to import all the functions. And then dollars is equals to integers parentheses amount. For the quarters, we are going to have quarters is equals to integers amount of dollars over 0.25. For the dimes, we have dimes is equals to integers amount of dollars minus quarters, which is 0.25 over 0.10. For the nickels, we have integers amount of dollars minus the quarters, which is 0.25 minus dimes, which is 0.10 over 0.05. For the pennies, we have integers amount of dollars minus quarters, which is 0.25, minus dimes, which is 0.10, and minus nickels, which is 0.05 over 0.01. For the totaling of the coins, we have total is equals to dollars plus quarters plus dimes plus nickels plus pennies. And then we are going to display the results. We have print, close parentheses, the codes, the number of coins in dollars, and the amount later on is, and the total later on. Then we are going to print the coins represented as dollars, quarters, dimes, nickels, and pennies. So we are going to run the code. So we have the number of coins in $1.56 is 5. The coins represented as $1, 2 quarters, 0 dimes, 1 nickel, and 1 penny. Let's move on to problem number 2. If the surface area of a spherical tank is 2000 square meters, we are going to solve the volume of the sphere. Our code will be from math. We are going to import all the functions. R is equals to float, parentheses input, parentheses the codes. We are going to enter the radius of the cone. And then volume is equals to 4 multiplied to 22 times the r cube over 3 times 7. Then we are going to print the volume of a spherical tank is the round volume 2. The formula for the volume is 4 thirds over 4 thirds pi r squared rather. Then we are going to run the code. We are going to enter the radius of the cone, which is 2000, and then enter. And there we go. We have the volume of a spherical tank is 33523809523.81. Then for problem number 3, we are going to find the volume of a right circular cone of radius 5 meters and the height 6 meters. Our code will be, we are going to import math. For R is equals to eval, parentheses, input, quotes, we are going to enter the radius in meters. H, represented as the height, is equals to eval, parentheses, input, parentheses, the quotes, and we are going to enter the height in meters. Then, for our formula, we have V is equals to pi r squared multiplied to the height over 3. And then we are going to print the volume of the right circular cone is, comma, V. We are going to run the code. We are going to enter the radius in meters, which is 5. Enter. the height in meters, which is 6, and we're going to enter. And there we go. We have the volume of the right circular cone is 157. And for the problem number 4, we are going to find the volume in cubic meter of an open top box having a dimension of 200 centimeter by 300 centimeter by 50 centimeter. We are going to import math again, and we are going to write the given. A is equals to 200, B is equals to 300, C is equals to 50. For the formula, we have the volume is equals to A times B times C. Then we are going to print the volume of an open top box is plus the string or the volume. And we are going to run the code. We have the volume of an open top box is 3 million. So this is in centimeters, and we are going to make this in cubic meter. And remember that 1 million centimeter is equal to 1 cubic meter. And we are going to divide it 3 million divided by 1 million. And we are going to run the code, and there we go. We have 3 cubic meters. The volume of an open top box is 3 cubic meter. For our problem number 5, a car accelerated from rest and reached the top speed of 120 miles per hour in 10 seconds. We are going to solve the acceleration of the car in kilometers per hour squared. We are going to import math, and the given we have the initial velocity in miles per hour, which is 0, and the final velocity in miles per hour, which is the 120, and we have the time in seconds, which is 10. And for our formula, we have the acceleration is equals to final velocity minus the initial velocity over time. And we are going to print the acceleration of the car is in the acceleration kilometers per hour squared. And we are going to run the code. And there we go. We have the acceleration of the car is 12.0 kilometers per hour squared. For our problem number 6, a body is dropped from the building and reached the ground in 8 seconds. What is the height of the building? And what is the velocity of the body as it hits the ground? So, we are going to evaluate. We have time is equals to eval input, and we are going to enter the time. We have from math, we are going to import all the functions. We have our gravity is equals to negative 9.8, and our initial velocity is equal to 0. For our formula, for the height, we have the distance is equals to initial velocity times time plus 1/2 multiplied to the gravity times time squared. And for the velocity, we have velocity is equals to initial velocity plus the gravity times time. And then we are going to print the height of the building is, and we have the absolute, and the velocity of the body as it hits the ground is in meter per second. And we are going to run the code, enter the time, which is 8 seconds. And there we go. We have the height of the building is 313.6, and the velocity of the body as it hits the ground is negative 78.4 meter per second. It is negative because of the statement a body is dropped from the building. So we have the positive. We have the negative rather. Sorry. Negative because it dropped from the building. And for our problem number 8, we are going to find the limit of x squared minus 25x over x minus 5 as x approaches 5. So we are going to have from SymPy, we are going to import all the functions and initialize underscore printing close parentheses. And the symbols, we have x is equals to symbols x. And we have L1 is equals to x squared minus 25x over x minus 5. And we are going to display the code. We have the uppercase limit L1 of x as x approaches 5. And there we go. We have our equation. We have the limit of x squared minus 25x over x minus 5 as x approaches 5. To solve for the limit of this, we are going to use the lowercase limit and the limit of L1 as x approaches 5. And then we are going to run the code. So we have the value of negative infinite. So for our challenge problem, we are going to find the equation of y is equals to mx plus b of a line passing 2 points a of negative 2 and 0 and b 3 and 6. And we are going to import math. We have x1 is equals to eval, which is to evaluate input, and we are going to enter the x1. The same as with the x2 is equals to eval input, and we are going to enter the x2. Do not forget the codes when we are writing a variable. And the y1 is equals to evaluate parentheses input, and we are going to enter the y1. y2 is equals to evaluate input, and we are going to enter the y2. So our formula will be m is equals to y2 minus y1 over x2 minus x1 for our m. For the slope, we are going to print the slope of the equation is and the formula in m. And for the b, we have b is equals to y1 minus the product of m multiplied to x1. And then we are going to print the y-intercept is in the formula of b, and we are going to print the equation of the line is y is equals to x plus blank, and I have used the format mb, and we are going to run the code. Then we are going to enter x1, which is negative 2, 3, the x2 is 3, the y1 is 0, and the y2 is 6. And there we go. We have the slope of the equation is 1.2, the y-intercept is 2.4, and the equation of the line is y is equals to 1.2x plus 2.4. In this lecture, I have learned many things on how to solve problems using Python. I have learned how to solve problems on volumes, equation of the lines, limits, the distribution of the coins, the height, the velocity, and also I have learned how to properly use the math modules, the codes, from math. We are going to import all the functions and import math. From SymPy, we are going to import all the functions, and it helps me enhance more on encoding, and most importantly is I learned a lot and I enjoyed the activity. Hopefully I will be able to learn more and explore more things about the world of Python. That would be all. Thank you.